Hi everybody, I'm going to talk about my poster named Chitosan Relation Properties Influenced by Sonication and Solar Drying Applied in the Biological Chitin Used for its Deacetylation. My name is Aurelius Medidan. I'm doing my postdoctoral research in the CIATEC subsede sureste. As introduction, chitosan is a subproduct of chitin. Uh, this molecule is a versatile due to amino or hydroxyl group of the molecule. That, that group can contribute to antibacterial, antioxidant, metal chelating, and gel forming properties due to create modification with other molecules to potentiate the biological properties. It's used in pharmaceutical industry for encapsulation bioactive compounds, in biomedicine to form films or gels to improve cicatrization. In cosmetic, is used to create skin cream to protect the skin, and in the water is used to remove heavy metals. In agriculture, is used to protect seeds or biocontrol to reduce the pesticides. In food industry, is used to form films and encapsulation to protect um, biocompounds sensible to the food processing. The methodology was consisted in that the biological chitin was submitted in sodium hydroxide for 72 hours. After that, was washed and sun dried. Then, the physicochemical properties and antibacterial properties was measured. And lastly, gel properties was evaluated. The result was found in this study was that the moisture was affected by the method we used. The values ranges from 0.36 to 2.50 for chitosan convection oven dried and chitosan sun dried system, respectively. The ash value was concentrated from biological chitin, and the values were 12.64 to 21% for chitosan oven dried and chitosan sun dried system. To consider a chitosan, the acetylation degree will be more than 50%, and the present study of the acetylation degree was ranged from 53 to 68% for chitosan sun-dried system and chitosan oven-dried. Solubility values range from 47.76 to 85.25 for chitosan oven-dried and chitosan sun-dried. According to the solubilization, only chitosan oven-dried and non-sonicated was not evaluated in the antibacterial activity. In this sense, the minimal concentration inhibitory for Escherichia coli was 19.53 microgram per milliliter, and Staphylococcus aureus was 0.12 microgram per milliliter for the chitosans studied. In the FTR spectra of chitosans, characteristics bands were observed at 3,358, showing the tension due to vibration of the nitrogen and hydrogen bonds in the primary amine. The peak at 2,920 represents the strength vibration for methyl groups. The bands of 1,637 correspond to the vibrations of acetyl group, and the peak of at 1,561 represent the vibration of secondary amine, and the band in 1,374 indicates the presence of remaining minerals in the molecules. In general, the gel remained stable during 48 hours of observation at 4 grade centigrade, except for chitosan convection oven dried, which represent a water loss of 58%. As a conclusion, the results indicate that chitosans with antibacterial properties and gelatic capacity can be efficiently obtained from chitin extracted through a biological process. Furthermore, solar drying emerged as a practical alternative to conventional convection oven drying, as it minimizes energy consumption from non-renewable sources while preserving the biological properties and gel forming capacity.